Guys, I think you remember when I did an unboxing video on the MDI unit, I mentioned that it has a problem with the RJ45 wired Ethernet connector. And it's actually not just this one I've got. I've had a second one that I had earlier that had the same problem. And I've run into somebody else who's talked to me about theirs that had the same problem. So it's like a generic defect with these guys. So we're going to try and fix that today. So I'm going to show you the problem first. I'm going to take this guy and I'm going to go ahead and hook him up to the laptop here and then show you the manifestation of the problem. And then we'll go ahead and talk about how to address the problem. So I'm going to go ahead and power the MDI up normal fashion. Get him through his power on self-test. I've got the MDI Manager up and running here. Did his chirp. And it did his beep. And he's ready to go. And so over here, as soon as he's detected, we'll go in and check his wired Ethernet configuration. Assuming I've got it plugged in all the way. There he goes. All right. Go ahead and connect. Got my check mark. Going to go into my network setup. My wired Ethernet I'm currently enabled, and I've got it set to do a DHCP server retrieval for the IP address, which is what I want to show for this first example. So I'm going to go back to the Explorer. I'm going to disconnect. I'm going to leave it powered on, but I'm going to disconnect the USB cable. And then to show you the problem, I'm actually going to come over to this window where I've got an SSH session into my edge router. And we're going to do a packet capture. If I can remember the right commands. And what we're looking here is, actually I probably want to do a different operator here. Port 67 and 68 will give us DHCP traffic on our internal LAN. And then I'm going to take the MDI and I'm going to connect up a wired Ethernet connection to it. We get our lights, and if we take a look over here on our packet capture, you start to see some activity. And what you'll end up seeing with this particular problem we're going to work on today is it'll be in an infinite loop with this particular set of messages. You can just see the timestamps rolling up here. You know, so this is constantly in a loop. So let's take a look at what the loop is. So I'm going to break out of the packet capture, and I'm going to open up this SSH window a little bit so that we can see what's going on. And so what we can see is we see a repeating situation of two DHCP messages. A discover message that's coming from the MDI unit, which is a broadcast message on port 67, and then a reply on port 68, which is an offer message from the DHCP server. But we never see the MDI unit say, I'll take it. I'll take that IP address that you're offering me, this 168.2.115 address that you're offering me, server. So that's the manifestation of the problem. The unit transmits okay, but it apparently doesn't receive. So let's open it up and let's take a look and see what that might be. So I'm going to disconnect the Ethernet cable and take the power off. I'm actually going to show you a little bit of another scenario with this. So one of the first things I did was I made myself a little test device, which was just a Cat5 RJ45 connector, and I wired up the relevant pins 1 and 2 and 3 and 6, which are my transmit and my receive pairs. And if I come over here and I take my multimeter and I put it on a continuity test, now what I'd expect to see is I expect to tone out pin 1 and 2 on this jack, and I'd expect to tone out pin 3 and 6. I get nothing. Nothing at all. Now if I was to take this connector and put it in a couple other examples, I'll show you. Here's an adapter for a MacBook, an Apple. Same kind of deal. You don't need power to do this test. Continuity on 1 and 2. Continuity on 3 and 6. I take this same little tester. It's a perfectly safe little test. I'm just going to take the laptop that we're actually using to do some of our filming today. And I'm going to stick it right in his RJ45 and do the same test. We're going to see continuity on 1 and 2, continuity on 3 and 6. So there's definitely an issue with the jack. And so we're going to go in to the MDI unit and see what that is. See if it's either a bad jack or a incomplete PCB on the circuit to enable it. So to open the guy up, just take off these little plastic covers on both ends, right? And then get rid of the battery door. And then we're going to bring some of the stuff out of the way first. Take a Phillips screwdriver. And I'd like to try and get this off without messing up this little sticker on the side. But we're going to remove these Phillips screws that are holding the two case halves together. It's the first time this guy's been opened, so some of them are in there pretty tight. And we'll get this guy right here on the other side. And again, this is a clone unit, so if this was a real MDI, we'd need to have a different tool to get these fasteners out because they're not Phillips heads in the real MDI. But they are in the clone. Okay. That one, and then this guy up here is just being a little bit stubborn. Got him loose now. Okay. All 4 of our connectors out. The only thing I said I wanted to do was I wanted to try and kind of preserve this little sticker that I have on the side here. We might be able to preserve it, or we might not, I don't know. Yes, we're able to preserve this guy. So sit him over there. And we got another little guy like that over here. I don't know if I can keep him. Yeah, we can get him too. Just a preference thing. If you don't care about that, you can just wax them right off. All right. Halves come apart. Pretty simple. And the unit dislodges from the case. And this is the high quality particular type version of this MDI clone. There's some that are cheaper and won't be as close to the original as this guy is. Spent a lot of time, as you saw in the unboxing video, before picking this. So this guy is held together by a couple of bridge connections here for this top board and the bottom board. So we are going to separate the two. I'm going to use a plastic spudger device. The board that holds the SD card and the computer board doesn't have any components on the other side, so I'm going to do my prizing on that connection, or on that side. Get this apart. Set this guy right here, because we're not going to do anything with the power board. And then here is the board we're interested in. So there's your Wi-Fi compact flash card. It's connected here. And this is the guy we're interested in. So we can see here the LAN controller chip. I know it's probably hard to see the writing on that, but it is an SMSC, and it's a 9116. So what we're going to do is we're going to pull the data sheet up for this guy, and we're going to see how this wires up. And what I'm going to do in the meantime is I'm going to go ahead and remove this jack. And this is, I can tell right now, this is a MagJack. So it's called a MagJack, where the magnetics for the isolation of the lines is inside the unit. There's not a separate device because we've just got the LAN controller chip itself and some surface mount resistors and capacitors on both sides that pertain to interfacing the lines, and then it's going right into the jack. And then here are the connections for the LEDs, the activity and the link light, which look like they probably are also driven by this same chip. So we're going to go ahead and unsolder this guy and get a better look at the circuitry underneath, and at the same time when we come back I'll show you the data sheet for this. So let's break and do that. Alright guys, down to just the last connector on here. Just using a simple sucker solder guy to get these off. Just making sure they're all good to go. Alright, let's see if we've got it to where we can get it to come loose. Just going to take this little X-Acto knife and check to see if he's ready to come off. Looks like that side's good. If you find that you're having trouble with it, whenever you're doing these kind of desoldering jobs, you just kind of see if you can find the pin that might have a little piece of solder still on it, because the last thing you want to do is damage any kind of traces. So it looks like the back's okay too. So I'm guessing it's probably the shield connector on this side. Might have a little bit still latching on. What to do on these is kind of come up from underneath them, let gravity kind of help me. Let's see if we happen to get it that time. Yep, that's it. Okay. It's just that shield connector was not wanting to let go. Alright, got them off. Okay, so what we're going to do now is we are going to clean up with some flux. And before I touch this hot desoldering iron, I'm going to turn that guy on, plug him, put a little bit of flux on here so that we can try and clean this up with our hand soldering pin. What we're trying to do is just where we might have had some solder still lingering on these connections. And then we're going to do the same thing on the other side. I'm just trying to work the tip of the soldering iron into the mounting holes, particularly around where we had these shield connections. That was where it was kind of stubborn. Everything looks nice, except this guy's got some all the way down in there. So we can get it from the other side. Okay, flip him over. We're going to do the same exact thing. A little bit more flux on here, so we can clean it up. Take our copper braid, just keep working these connections. Now, this is standard stuff. You know, if you know what you're doing here, you can kind of fast forward through if you like. I'm just going to show them this in case folks aren't used to doing it. I'm going to clean it up some more before we go to the repair stage, but I'm just going to try to do this prep part first as much as I can. And yes, normally I'd have a flux fume extractor going, but the one I've got is pretty noisy, and you wouldn't be able to hear anything I'm saying here, so we are just going to take a small risk for a second. I'm going to want to come back to these ones that we're holding the shield later, but I think that's good enough for now. The main thing I'm trying to do is just get this clean enough so we can take a look at the circuit itself. So I'm going to take a Q-tip here, take some isopropyl alcohol, not the water kind, 91% or higher. Just try to clean this up, off any flux that was left on here. All right. Let's see what we got. So, if we take a look here, so we can see these are the pins 1 through 8 for 100. This is a 10-100 jack. 2 shield connections, 2 alignment pins, and then our pins that cook up our LEDs. here we can see our LAN connector, and if we reference, like I said I would pull it up, if we reference over here on the laptop the reference schematic, what we're looking at here are there's only 4 pins we really need to be concerned with. 2 plus and minus for output and 2 plus and minus for input. And those 2 input ones are the ones we're interested in. And they cross over to a couple of capacitors, then go over. This is an external magnetics unit. We're running a MagJack, so it'll be a little bit different. And then this would be the output, which we know is working. You see there's an array of 4 49.9 resistors, and there's some other capacitors. And I'm not going to try to verify this whole circuit. I'm just going to do a quick check and see if it's similar, because I'm guessing that they might have went with the reference of the manufacturer of the physical interface. So if we take a look at this, and hopefully this will show up for you, because I don't have a setup where I can do my microscope like that. But what we find is we do have some 49.9 k ohm resistors on this side, and if we turn on the other side, we find we've got a similar situation. So this looks like a comparable circuit. And then what I can see over here is I can see that I've got pin 3 to the MagJack. You can see that, and pin 3 is connected, pin 1's connected, and pin 2's connected. Pin 4 and 5 are grounded out, so they're not used. So that would leave 6, 7, and 8, as well as 1, 2, and 3 as the pins that are active. We go back on the other side and take a look at the circuit. So far the circuit's looking like it is complete. We see 7 and 8 are part of what's wired up, so we can see the traces going to 7 and 8. And we can see a trace going to 6, 1, 2, and 3. When we follow these traces over for 1 and 2, you can see they come in to the top of the LAN chip, and that would indicate the output. So that would mean that our input is 7 and 8. So it looks like they're wired up, so maybe it's just the jack. So let me show you something about these jacks, and then I'll show you what we're going to try to see if we can fix this. So there's a number of different magnetic jacks, and I pulled up a couple of examples for you. I mean, here's an example of a, let's see, this is an example of a particular company called EDAC. And what you'll find, I'm going to show you just the 100s, because these are 1 gigs. Let's see, 100s. 1 gig, 1 gig, gig. I think this is one here. Nope, that's 1 gig. Bear with me a second. There's lots. That's one of the first things you'll find when trying to find a replacement part like this. There is a lot of different choices. Even when we get down through, here we go. Here's a 10100 part. So here's a 10100 part with LEDs. It's got EMI fingers on it. If we look at the original one we've got, it's got a shield on it, but it's got none of these fingers. That's okay. It's just a cosmetic difference. It looks like it's similar to what we want. We come down here and we take a look at the layout of the pins, and get my little pointer here, and we can see we want a staggered layout where we want the LED pins in the front, and we do have that. We got our 2 alignment pins and our 2 shield solder connections. That looks good. But if we take a look at the actual 8 pins, we see that they might, I mean, you want to see that they're lined up in a staggered row as well. We're going to see that there are some that don't look like that, and I'll show you one of those in a minute. So this looks like the right one, because we're looking at this guy upside down, right? So he's going to plug into that, so don't be alarmed by that difference. But when we look at the circuit that this one has, we can see that it requires pins 1 and 2, 3 and 6, and then 4 and 5 is the center taps for these internal transformers that are inside the MagJack. And we know that doesn't work for this circuit because 4 and 5 are tied to ground. So this is not a good match for us. If we keep going through here, we see here's another one. This one has a different pin out entirely with 10 pins, so that's not going to work for us. We keep going through here. First thing we got to do is we got to go through all these ones and find something that might work for us. Here's one that's got 7 and 8 with 6 as a center tap. That's good, but we need 1 and 2 and 3 as a center tap. So this one isn't going to work for us either, internal wise. Now this is what we want. 1 and 2 with 3 as a center tap, 7 and 8 with 6 as a center tap, 4 and 5 tied to ground. This is the right circuit. It's the wrong pinout, because as we see, we need our LED pieces in the front, our holes for LEDs in the front. In this case, they're in the back. So this is what I found in trying to find a part for this. There's all kinds of these things, and you either find with no LEDs, or you find with LEDs but the wrong place. And so the long story short, to save you guys, what I ended up finding out was that you can get something from SparkFun. I think actually here's what I got. Expand it for it. You can get it from SparkFun, and they sell this little MagJack. And it turns out when I look at this little MagJack, I've got the right LED locations, alignment, and solder shield pins, and I've got the right 8 pins here. It still has the EMI fingers, but that's, you know, like I said, it's cosmetic. And you find out, bingo, 1 and 2 with 3 as a center tap, 7 and 7 and 8 with 6 as a center tap. This is the thing we want in terms of how it's wired, and I happen to have been able to locate one of these, and this is what I got. I'm going to actually tear this up, but this came off of a prototyping board, and little did I know that right here is what I need, so I don't have to actually try and track down the actual jack. I can sacrifice my little board here, and that's what I'm going to take off, and I'm going to put this on our MDI, and hopefully we're going to be in business. And so, you know, even the other thing you have to notice is that these LED colors, so I'm looking for a yellow and a green. That's a yellow and a green. You can find green and green, green and yellow, yellow and yellow, red, all different kind of colors. You just got to go through all these different combinations. So I'm going to desolder this MagJack off of this SparkFun prototype board, because I believe it is the right circuit that we want. I'm going to put it on our MDI. We're going to retest it. So we'll come back in a minute. I think we've got this loose. Just have a little bit more. This back one. Got to be even more patient with this one, because this is our replacement one, so we definitely don't want it to be damaged. All right. Just a little bit stuck on the solder shield itself. I don't want to force it, so we're going to have to fire up the other iron. I don't think I can get it with this one. I'll try. Might be able to get it. No, it's a piece just latched in there, and it's kind of stuck. The only thing we're held on by at the present is the shield solder lug. So we will try to dislodge that with the regular soldering iron. Goes. Guess he had maybe I didn't notice it. There might have been a little bit of a bend to it. Keep it from coming out, I guess. Alright, we've got him off now. Let's set this little SparkFun board aside. This is what we're after. This hopefully is going to be our replacement MagJack and get this guy working again. So everything looks good. I went ahead and cleaned this up some more with the no flux solder, and the copper, and the copper braid. Just going to give it one more pass with an alcohol swab, and then we're going to reattach, or we're going to attach this new one. So hopefully all this is going to be fine. And he's going to line right up with these pins. And if he's not, just take a moment, straighten him out. Okay, looks good in the back. Still a little bent on the LED side. There he goes. All right, got him in there. So now I'm just going to solder him in, and then we'll come back, put it back together, and hopefully we've got a working wired Ethernet. So let me just start touching the solder up on this, and we'll come back. Almost done, guys. I'm just doing the last couple here. So bear with me. Can't see it as well with the camera there, but I think it's coming out okay. All right, looks good. Again, just, you know, hopefully that gives you a good view of what we did here. We got this guy all nice and soldered in here. All right, I like to put a little towel on here just to keep it pressed tightly against it. A little power button. I don't want to lose that. All right, so moment of truth. Let's put it back together. So we're going to put our two case halves back first. This only goes a certain way, obviously, but it is possible, because the nature of this connector, it is possible to get it off center. I'm just going to show you. And if you were to power it up like that with it pushed in, you'd blow it out. So very important, make sure that it is perfectly centered in here and snaps in. And then something else, you know, I suggest you do, you know, make sure that it's perfectly lined up. You can use these screws to make sure that everything is where it's supposed to be. All right, so that way you don't fry the thing. All right, so again, we got our little power button that we do not want to lose. We're going to take the back side, which is the side with the batteries, and there's two pieces that come through here, and that'll probably be the next project, because these batteries aren't actually functional. I took a quick look at that circuit, and it's there, but it's depopulated, so they must have ran into a problem getting the battery system to work. All right, so get that guy in there, make sure he's sitting where he's supposed to go, all nice and lined up. Okay, good. And then I'm just going to, so I can see that I left some fingerprints on this tin that holds this SD connector, and I just don't want that to tarnish. So I'm just going to take a little bit of alcohol, get that off. Hopefully that won't be a problem down the road, because I won't open this thing up again unless I decide to chase the battery problem. All right, and then we're going to put the top piece on, make sure our power button lines up. Good. Okay. We are in good shape, kind of good shape. Forgot to salvage our little sticker over here, so oh well. He did not survive. Put our 4 screws back in. Phillips screws. And the bottom, the other side of the case has a little brass threaded insert, just kind of good. It's what the original MDI would have, so you don't have to worry about possibly stripping out the screw going into plastic. That's not a problem. Okay, nice and snug, and we are going to put our battery door back on, and we're going to put our side cover back on here, and we're going to put our back cover on here. Okay, and we get it all back together again, and let's show that we don't have the original problem. So I'm going to fire up the multimeter again, and we're going to set it on continuity test. Get our probes over here, 1 and 2, 3 and 4. Right, we got a jack that's doing what we expect it to do. Now let's see if it actually works. So let's step back over to the laptop, and we're going to power it back on. Moment of truth, right? Yay, green lights. I didn't screw anything up. It's the beginning of a good day. Going through the power on self-test. Waiting for our chirp. There's our chirp, waiting for our beep. There's our beep. Okay, let's hook up our USB cable, and let's first start, make sure that MDI Manager is still talking to this guy. Okay, there he is. I can connect. Again, we're just making sure that we're still good to go here with the wired Ethernet enable for DHCP. Great. We're going to disconnect, and then we're going to take the USB cable out, and we are going to fire up our packet capture on the router again, and we're going to reconnect our cable. Okay, and now we're actually getting some blinking, so I think this is a good sign. And so, yes, I got an offer, I got a request, and I got an acknowledgement. So, Ethernet is now correctly working for DHCP. Now let's see if the MDI is seeing it over the internet, or excuse me, over the Ethernet. That would be the last test here. And I've never done this since it hasn't worked, so I don't know how long this actually takes. I've done it with Wi-Fi, and it does take a little bit longer than USB to see it. When you see on Wi-Fi, you'll see like little bars here that indicate that it's connected. So I'm just going to give it a shot and see if it sees the MDI, and then while I'm waiting, I'm going to go ahead and break out of this. And I'm just going to do a test ping to that IP address that was assigned, which I believe was 115 right here. The IP that these guys negotiated amongst themselves, and the MDI is responding to a ping, so that's goodness. But we don't have the MDI Manager seeing it yet, so I'm gonna have to debug this a little bit more. It might be just a problem with the packets being blocked inside my LAN by the router or one of the switches. So let me pause and take a look at that. But we're almost there. We have the jack working. And we have, like, for example, now if I do the ping, we didn't have it before because it was just kind of a solid situation. Now we actually have blinking traffic indicator because we're actually getting traffic back and forth because we're able to ping the device. So the hardware is working now. So we actually fixed the hardware. Now we have to just work on a software problem. Back in just a minute. I thought it was a switch problem. So I just to save some time, I've switched to a different PC I have in my home network here and a different switch over to the the router itself. So we can see the MDI is not detected. I'm running the MDI Manager on this particular Windows 10 PC. I've got the MDI right here on this desk. It's all powered up and ready to go, and I've got him plugged into the switch this desktop computer uses. I'm going to plug him in, and then we're going to watch the MDI Manager detect him. And you can see, like I was mentioning before, this is the symbol for a wired Ethernet connection. If it's USB, you've seen the USB symbol, and if it's Wi-Fi, you'll get a signal bar icon on there. And when you connect this up, you can connect it just like you can with USB, although it's kind of limited what you can do. You can look at the properties, but you can't actually configure anything over either wired or Wi-Fi. You have to use USB to actually configure anything. But it does at least it lets you connect it up and know that everything's working. So it's successful. We fixed it. And if you happen to have this particular type of high-quality MDI clone and it's got this particular serial number, because they're all the same, then this is the fix to get wired Ethernet working. I hope this helped you out. If it did, please like and subscribe. Thanks for watching.